Rationals are like fractions, and they follow fraction rules, which often make kids, when they hear fractions, doesn't matter what age, cringe a little. Fractions, I don't know why they have such a bad rap, but they do. They're like the unliked friend, you know? Like the friend that's really good and needy and helpful, and you just don't like them because you just don't want to. That's why. That's what I feel like fraction is. It's a bad rap. You know, it pulls its weight, it makes it so you can bake, cook, you know? That's what fractions are good for. All these things, but no, people don't like them. Could you even bake without fractions? Probably not. Not well, that's for sure. So, let's give fractions, you know, their dues, and be kind to them. Fractions are a good thing. Rationals are fractions with variables. Because what's better than a fraction? A fraction with variables. Right? Right? Right. Totally. Yeah. Accurate. Okay. So a rational expression is like, say I give you x plus 1 over x plus 3. That would be a rational expression. It's where you have variables in it. So it's not just a fraction, because fractions are fun. It's an amped up fraction. It has variables. Like, you thought today couldn't get any better. Well, you were wrong. So much better. All right. The rule of fractions, often that we haven't had to worry about, is we have like 1/3 or 1/2 or 1/4, we have fractions, and they're just numbers. And everything's fine. The problem in math is you're not allowed to divide by what? Anyone remember? That you can't divide by? Yes. 0. You can't divide by... That was you, Alex. I don't know why you were looking for someone else. You were doing the 0. It was him. He's not taking credit. He's correct. Okay? So he's paying attention. It is 0. You are not allowed to divide by 0. Now, for all those of you who are like, okay, sure, whatever you say. Type 7 divided by 0 into your calculator. 7. Go ahead. Pay a lot of money for those calculators. Use them. 7 divided by 0. He's like, I'll just try. 7 divided by 0, what does it do?
Error.
It says error. It is not happy. Okay? Not happy. You're not allowed to divide by 0. Now go 0 divided by 7. Put the 0 in the numerator now. 0 divided by 7, what happens? We get 0. Totally fine, right? So our numerator can be 0, but our denominator cannot be 0. So until now, we haven't had to state non-permissible values. Non-permissible values come up because our denominator, the bottom of our fraction, can't equal 0. That is why we have restrictions. Most of the time when we have fractions, we don't have restrictions because it's 1/3. Well, 3 is in the denominator. 3 isn't 0. No problems, correct? Non-permissible values and restrictions come up when we actually have variables in our denominator. Because the moment we have variables in our denominator, that variable can be any number in the world, correct? So we have to state what it can't be, because if it was that, it would make the denominator 0. So those are what the non-permissible values are. So if I look at the example I used up here, I have x plus 1 over x plus 3. Now, I know that this can't equal what? What did we say? The denominator can't equal what? 0. We agree? So what would the x be that would make the denominator 0? What would I add to 3 that would make this be 0? -3. Someone's whispering it, and they are correct. So if I go -3 plus 3, this turns into a 0, doesn't it? Doesn't matter that -3 plus 1 is -2 in the numerator. I don't really care what the numerator is. The numerator can actually be 0. It doesn't matter. It's the denominator that's the problem. And right now, because these are x's, x can be anything. It can be 1, -1, 0.3, pi, 2.94, 2 million. X can be anything, correct? But what we have to do is we have to state all the values that x can't be, because if it was that, my denominator would be 0. That is what a non-permissible value is. If it was that, it would make my denominator 0. So how you can do that is you can visualize it here, or you can say x plus 3 can't equal what? Pull something. I should have stretched first while running. X plus 3 can't equal what? 0. Colton's not distracting himself, he's distracting others. All right. So how do I get x by itself? I need to move the plus 3. How do I move it? Subtract 3. Now you might be like, this is ridiculous. It was 3. It was negative 3. I could just tell. Yes, but they aren't always this easy. So we're showing how you can actually calculate it. So x can't equal negative 3. Now if you plug it back in, you get negative 3 plus 3 is 0, right? So you know you're right. If you plugged your non-permissible value back into your denominator and it equaled 0, you were correct. Because you found the number that would make it be 0, and so x can't be that. Okay, well, what if it's a harder one? What if it's 3x over 2x minus 1? Now, the 2x minus 1 isn't as obvious as the x plus 3. X plus 3 is negative 3, right? That's way more obvious. But the 2x minus 1, is it as obvious? No. So I can still use the same steps I used in the previous one. That denominator can't equal what? 0. And then what do I do? What do I have to move first? Yeah. You add 1. And then divide. So in this case, x can't equal a half. So that's what my restriction is. X can't equal a half. If they ask you what are the non-permissible values, you'd say x equals a half is the non-permissible value, right? If you say, well, it can't be, x can't equal a half, that would be true. So if they ask you what the non-permissible value is, and the answer they have in the multiple choice is x equals a half, that's true. That is the non-permissible value, right? So it doesn't have to have an not equal to if you say the non-permissible value is x equals a half, or whatever. Now if I plug that back into my denominator, I get 2 times a half, which is 1. 1 minus 1 is 0. So I know I'm right, because the denominator, once again, turned to 0. Okay? So here are the steps, because those ones I gave you were more simple. The steps to find non-permissible values. So sometimes they ask us to just find non-permissible values on the test. On the diploma, it's usually one question. Okay? Where they ask you for the non-permissible value in some format. Now, the non-permissible values are only dependent on the denominator. So I wouldn't actually have to do anything to the numerator if the question is just blatantly what is the non-permissible values or what are the restrictions. I could care less. The top could have a picture of a pig. It does not matter what the top has, right? If all they're asking you for is the non-permissible values. But you do have to get your denominator in the most simplest form in order to get your NPVs. So the first steps are to do the greatest common factor or difference of squares if possible, the denominator. You always will factor it. And then you'll take each of them denominator pieces and set them not equal to 0 and solve. So here, this one has example 1. Consider the rational expression x plus 1 all over 5x squared minus 5x. So the first thing I have to do is, I'm going to rewrite it here. It wants the non-permissible values, x plus 1, and then 5x squared minus 5x. I can keep the top the same, because it doesn't really matter what the top has, because I don't care about the numerator, because the numerator has nothing to do with non-permissible values, right? The denominator, is there something I can do? GCF or difference of squares it? Yeah, what could I do? Take out a 5x. So if I take a 5x out, this is what we went over and reviewed yesterday for. If I take the 5x out, 5x squared divided by 5x is just x. And then what's negative 5x divided by 5x? Minus 1. That's why we did all this GCF and difference of squares yesterday, was to set us up for rationals. Now, I used to not do this, but I do this now all the time because I found it made people make less mistakes. The x minus 1 are sewn together, right? You can treat the minus sign and the plus sign as if it's like stitching, like they sewed them together. So the x is here, the 1 is here, and the minus sign sews them together. So they're stuck together as one whole thing. That's why there's brackets around them. We agree? But the 5 and the x, do they have like a plus or minus sign sewing them together? No. So they're completely separate, correct? So if they're separate, I can actually put them in their own brackets. So 2 multiplied things without a plus or minus sign can go in their own brackets. Now, every bracket that has a variable in it, will get you a non-permissible value. Every bracket that has a variable in it. So how many brackets have a variable in it? Out of the 3, how many have a letter in it? 2. So how many non-permissible values am I going to get? 2. Because I would take each of these and set them not equal to 0. So I'll try the 5 first. 5 can't equal 0. Very accurate. 5 can't equal 0. 5 equals 5. Is there a variable anywhere in that? So no non-permissible values are going to come out of that. So when you just have a number can't equal 0, you can write it, but it doesn't do anything. So I'm just going to cross it out. Then I have 2 blanks, or 2 brackets, that have variables in them. And those will each result in a non-permissible value. Okay? So my first one is just x. So x can't equal 0. True statement. Put a bracket around it. Then the next one is x minus 1 can't equal 0. So x can't equal 1. That's my other one. Now remember I told you with non-permissible values, you'll always know you're right because you can plug it back into the original, and if the denominator becomes 0, you were right. Because these are the values that can't exist. So let's try them out. So I have 5x squared minus 5x. And if it gets me a 0 when I plug in each of these separately, then I know I'm correct. I can walk away knowing I got the question completely right. I have the right NPVs. Okay? So I'm going to plug a 0 in first. So I go 5 times 0 squared minus 5 times 0. Well, that's 0 minus 0, which is 0. So this one's good, right? It resulted in making that denominator 0, didn't it? So I know that's good. Then I plug the 1 in. I get 5x squared minus 5x. And I get 5 times 1 squared minus 5 times 1, which is 5 minus 5, which is 0. So that one's good as well. And they'll often write them together. So they'll often say x can't equal 0, comma 1, and put a bracket, or put a box around it. Now, B. B says state the restrictions on the variable. So the first one, A, was the non-permissible values. B are the restrictions, what we restrict the x to be. Those are just the exact same way of saying the exact same thing. Remember in grade 10 and 11, they talk about zeros, roots, x-intercepts. They're all the same thing. They all mean x-intercepts, zeros, roots, and x-intercepts. It's just the same meaning of 3 different words. Same thing here. If I ask for restrictions or I ask for non-permissible values, it means the same thing. So B's answer to B is the same answer as A because they are asking for the exact same thing. Now the restrictions, you could say x can't equal 0 and 1. The non-permissible values, you could actually write are x equals 0 and 1. Because if I'm stating the non-permissible values, that's what they equal. The restrictions are what they don't equal. So the difference between the two would be 1 would be not equal to and 1 could be equal to. Right? If you're stating restrictions, but you're restricting it not to be. All right. So here we're going to go down to these ones. It says, determine the non-permissible values or restrictions for each of the following expressions. So I have 3a minus 1 over a minus 1. Do I care what's in the top if I'm only asking for restrictions? No, I only care about the bottom. Before I go to do my restrictions, I always check my denominator. Can I factor it, which is the difference of squares, or can I take out a GCF? Can I do either of those things to this denominator? No, there's nothing I can do. Are the a and the 1 sewn together? Is there stitching? Is there a plus or minus sign between them? Yes, there is a minus sign between the a and the 1. We agree? So we have an a, we have a 1, and the minus sign stitches them together. How do I show that they're stitched together? I put brackets around them. That's how I show that the a and the 1 are stitched together. Okay? They have brackets around them. Now remember, every bracket with a variable will result in a restriction. We agree? So how many brackets do I have with a variable? I have 1. How many restrictions am I going to get? 1. That's it. All I do is I take that bracket, I set it not equal to 0. So I go a minus 1 can't equal 0. A can't equal 1. Done. And I should be able to check it by plugging it back into the denominator. 1 minus 1 is 0. So I know I'm right. Now if the variable is a and you choose to write x can't equal 1, are you going to get any marks? No, you're stating some sort of restriction of an x that doesn't exist in the world. Like there's no x in this question, right? So you can't just be like, I like x's better, so I'm going to write an x. If the variable is a, you have to write a, because a can't equal 1. If you say x can't equal 1, I'd look here and be like, well, there's no x's. What are you talking about? Right? So you have to keep the variable. You see that? So B, before I go to do B, I have to ask myself, can I take a GCF out of the denominator, or is it a difference of squares? GCF. What can I take out of this denominator? I think I heard someone whisper K. K is correct. When I take a K out of 2K squared, I'm left with 2K. When I take a K out of negative K, I'm left with negative 1. And those are my two brackets. Okay, how many brackets do I have? 2. How many brackets do I have with variables in them? 2. How many NPVs restrictions am I going to have? 2. You see how there's a correlation here of what we get here. So every bracket that has a variable will get a different restriction. So here we have K can't equal 0. And that one's done. And then this one we get 2K minus 1 can't equal 0. Add 1. 2K can't equal 1. Divide by 2. And K can't equal a half. Then like I said, they'll put them together. So they'll go K can't equal 0 or a half. I want you guys to try C and D. So we're going to do C. Like I said, even if you could do something to numerator, just because they're only asking for non-permissible values, we don't have to. Don't worry, on Friday we'll have to. So enjoy your one day where you can literally just look at the denominator and nothing else. Okay? Here's your one day. Enjoy it. Don't overdo it. So on the bottom here, I can take a 2 out, and I'm left with m plus 5. Now remember that the 2 goes in its own brackets. Now, how many brackets do I have? How many different brackets do I have? I have 2. But how many brackets have a variable? 1. So how many NPVs am I going to have? 1. Only the amount of NPVs you get are equal to how many brackets have a variable in it, right? Because this one I can say 2 can't equal 0, which is a true statement, but doesn't get me an NPV, correct? And then this one, I get m plus 5 can't equal 0, and move the 5 over, m can't equal negative 5. What's up with D, the denominator of D? It's a what? Difference of squares. Now remember, I told you this before, and I'll tell you this till the end of time, that if you're stuck and you can't figure out how to do something, and you're like, it's way harder than it should be, most often you're missing a difference of squares. You're just not factoring it, you're not seeing it. So should be noticeable to you, it's always 2 terms with a minus sign. So whenever there's anything with 2 terms and a minus sign, I'm checking for difference of squares. Now it's not always difference of squares, sometimes it's just a GCF or nothing. But if there's 2 terms with a minus sign, I will always check for difference of squares. So it has the difference sign, which we need. The square root of x squared is x. Square root of 49 is 7. So I'm going to get x plus 7 and x minus 7. Now, how many brackets do I have in the denominator? I have 2. How many of them have variables? 2. How many NPVs am I going to get? 2. And these have brackets because the x and the 7 have a plus sign between them. So they're sewn together, and how do I show that? With brackets. The x and the other 7 are sewn together with a minus sign. How do I show that? With brackets. So that's why you put the brackets around, because that's how you can show that those terms are actually held together. So now we have x plus 7 can't equal 0. X can't equal negative 7. And this one's x minus 7 can't equal 0. X can't equal 7 by moving them over. And you'll often write them together as x can't equal plus or minus 7, like this. So there's a your term with an A and a B and a C and a D. Try them out. So for A, for this particular question, when I ask for non-permissible values, make sure your phones are awake, because I'm not doing this for my benefit. I'm really good at rationals, because I've been doing it since NOM. That's the only reason why I'm really good at it. But let's pretend this is a smiley face. Does it matter what that is up there? It could be a piglet. Didn't have legs, it's just floating. Okay, it could be whatever. It kind of looks like a cat, but whatever. It could be whatever on the top, because we do not care about the top if it says non-permissible values. Only if it says non-permissible values or restrictions, we do not care about the top. If it says simplify, yes, we're going to have to do a whole bunch more work. But when it says just non-permissible values or restrictions, be like, yay, I don't give a crap about the numerator. Like, it doesn't matter. You know, throw a little party in your head, not out for everyone else. All right. So we only care about the denominators. Great thing about 30-2 is it's not 20-1. That's the great thing about 30-2. In 20-1, if you were in it, you actually had options at the bottom. You could GCF, or you could difference of squares, or you could product sum, or you could decomp. So you could have like trinomials on the bottom. Okay? Not in 30-2. No trinomials. If there's a trinomial, all they can ask you to do is take out a GCF. So if there's a trinomial, don't be like, oh, I'm going to have to factor it. No, they can't. It's like in the curriculum. It literally says no trinomial factor. Like you're not allowed to. It says GCF and difference of squares. That's what my curriculum says. So you're not allowed to do anything else. Feel like I am putting a cast spell on you or something. Yeah, so you can't have that. So if you have a trinomial in the denominator, the biggest I can make you do is take out a GCF. Okay? So what's great about for you guys is you don't have the trinomial problems. The only options you have are GCF or difference of squares. That's it. If you can't take out a GCF, you can't do a difference of squares, you put it in brackets because that's all you can do. You can't do anything else. Okay? 2 options. Great thing. Going from 4 options to 2. That cuts them in half. It's great. Okay? So I look here and I immediately see it as not a difference of squares because the x isn't even squared, right? So I know it's not a difference of squares. So what's the only thing I could possibly have as an option? Only one option. GCF. That is it. That is all. That's all I have. Correct? And I say to myself, what can I take out of here? So I'm going to take out a -2. And when I take a -2 out of -2x, I get x. -4 divided by -2 is +2. Now these are sewn together with a plus sign, so I put brackets around them. This one's by itself. I have 2 brackets. Of the 2 brackets, one of them has a variable, one of them does not. Correct? So I'm only going to have 1 NPV because I have 1 bracket with a variable. And you can write this one out if you want. You can go -2 can't equal 0. True statement of no help to us. So I'm just like, no, don't need you, right? So you could show that, but then you cross it off because it doesn't get you an NPV because it doesn't have a variable. -2 can never be 0. Then I go x plus 2 can't equal 0. Subtract my 2 over. And x can't equal -2. That's it. Now b, I look at the denominator of this cat-pig thing I've got going on here. That stays up there. I don't really care. This is a difference of squares. So I say square root of a squared is a. Square root of 81 is 9. And I have a difference sign. If I do not have a difference sign, if I have an addition sign, it is an addition of squares, and you can do nothing. You can put it in brackets. That's about all you can do. Okay? But a difference of squares I can factor. I can get a plus 9, a minus 9. So I'm going to set them both equal to 0. I have 2 brackets with 2 variables. I'm going to get 2 NPVs. So I get a plus 9 can't equal 0. A minus 9 can't equal 0. A can't equal -9. A can't equal 9. So a can't equal plus or minus 9. Now this one, C, I ask myself of just the denominator, is there a GCF or a difference of squares? Well, it can't be a difference of squares because P is not squared, right? So maximum I can take out a GCF. I'm not even fixing it, I'm just leaving it. So I can take out a P, just a P. When I go 4P squared, take out a P, I'm left with 4P. And then -P, take out a P, I'm left with -1. The 4P and the 1 are sewn together by the -1, and I represent that with brackets, correct? And then the P is in its own bracket. I have 2 brackets. Both brackets have a variable. So I'm going to get 2 NPVs. So I'm going to go P can't equal 0. And 4P minus 1 can't equal 0. 4P can't equal 1. Divide them by 4. P can't equal a quarter. So I go P can't equal 0 or a quarter. Now if I look at D, D is trick. Most of you will not have this right. D has a trick. I see this and I say, okay, I can take a 2 out. The top just stays the same, I don't really care about that. I can take a 2 out of the bottom, and I'm left with x squared plus 4. Now people will say to me, okay, well I know the 2 doesn't get me an NPV, but this bracket has an x in it, so it must give me an NPV. Or they want to try and factor it and go x plus 4, x minus 4. You can't do that. It's not a difference of squares, it's an addition of squares. You can't actually factor it. You should be happy when you see an addition of squares because there's nothing you can do with it. It would just sit in that bracket, there's nothing you can do. Okay? Now, I know 2 can't equal 0 would be a comment, but no variable in it, so no NPV. This one is x squared plus 4. I can't make it any better. Can't equal 0. I subtract the 4 over, so I go x squared can't equal negative 4. And then I take the square root and I put plus or minus. But I actually can't square root a negative number. This is not possible. Right? Not possible. So there are actually no NPVs. Now let's make it make sense rather than just saying, well, it doesn't happen. NPVs happen when your denominator becomes 0. We agree? That's when you get a non-permissible value, is when your denominator becomes 0. So let's actually look at this denominator here. This denominator here we have is 2x squared plus 8. We agree? The only way I can make this denominator be 0 is if I can turn this 2x squared somehow into a negative 8. Because negative 8 plus 8 is 0. Do you see what I'm saying? So the only way I can make my denominator be 0 is if I could turn this 2x squared into a negative 8. What's the catch when you square any number? If you square a positive number or you square a negative number, what happens to the number? It comes out positive. If I square 2, 2 squared is 4. If I square negative 2 squared is negative 2 times negative 2, which is 4. Any number squared means you multiply it by itself twice, correct? So whether you have 2 positives multiplied, you'll get a positive, or 2 negatives multiplied, you get a positive. We agree? So if I square anything, this is going to be positive. What's a positive plus 8? Always a positive number. You're just going to get larger numbers here. There's no number I can fill in for x that would get this to be negative 8. Like even if I filled in negative 2. Negative 2 squared is positive 4. Positive 4 times 2 is 8. 8 plus 8 is 16, not 0. Right? So whenever you have an addition of squares, you will get no NPVs from that block. You will get none. Does that make sense? Okay. One last thing I want to go over with you is equivalence. You did equivalent fractions since little. Equivalent fractions are something like they gave you a piece of pizza. They gave you a pizza, right? And they cut it into 4 pieces. And they shaded one. And they said, oh, you get to eat 1 out of 4 pieces, right? Remember in elementary school? They'd give you like a piece of pizza, or a pizza cut into 4 and shade 1. And they'd be like, wow, you get to eat 1 out of 4 pieces. And you'd be like, yeah, it's exciting. And then they'd be like, oh, what happens if we cut them all in half? And then you went and you thought your life was hard at that point, and then you realize now it was super easy. And you cut them all in half. And now they said, well, now how many pieces did you get to eat? And you'd be like, 2, I get to eat 2. And it's like, out of 8. You just got smaller pieces. But you still have the same amount of pizza, correct? The first one you had 1 out of 4 pieces. The second one you had 2 out of 8 pieces. But in the end, you actually still have the same amount of pizza that you're eating, because those are equivalent fractions, right? And they taught you that if you had equivalent fractions, you just have to multiply the top and the bottom by the same thing, or the numerator and denominator, or you divided the numerator and denominator by the same thing, and then you just reduce the fraction or make it bigger, and it was still the same fraction though, right? Just like a half is the same as 2 over 4. That's still a half, right? So, if we go back to the example of 8 over 12, we could technically divide the top by 4 and divide the bottom by 4, and we get 2 over 3, and that would be an equivalent fraction to 8/12, right? We just reduced the fraction. So that is equivalent. But instead of dividing the top and the bottom by the same thing with equivalent, you could actually also multiply. So I could multiply the top by 2, multiply the bottom by 2, and now I have 16 out of 24 pieces, and I feel like I've got like so many pieces to eat. They're just all a sliver, like just a pizza's just a sliver piece, right? But it's still equivalent. So what if we get rationals? Well, if we're trying to find an equivalent rational, same thing. We either divide the top and the bottom by the same thing, or we multiply the top and the bottom by the same thing. So if I look at this one, I have 4x squared plus 8x over 4x. What could I take out of everything? Remember, you have to, if you're going to divide, you have to be able to take it out of everything if you're doing equivalent. Not simplifying, we're doing equivalent. So someone said I could divide by 4. Yep. I could also divide them by 2. I could also divide them by x. I could also divide them by 4x or 2x, right? Any of those would get me equivalent. So I'm going to do 4. Divide the top and the bottom by 4. On the top, if I take a 4 out, I'm left with x squared plus 2x. And on the bottom, I'm left with just x. So this would be equivalent to that. It's just reduced. But instead of dividing, what else could I do? Instead of dividing, I could multiply. So I could take the same exact original. And I could multiply by 2. And I would get 8x squared plus 16x over 8x. Remember, you have a test tomorrow on both units.